Hello everyone. Today we are starting the next topic of Unit 1, that is networks model. The most used software in the network is equally important as the hardware. The network software is highly structured nowadays. For that structured programming, we are using protocol hierarchies, that is layered architecture. Most networks are organizing in the form of series of layer of level as shown in the figure. To reduce the design complexity, layered architecture is used. The number of layers, the name of each layer, the content of each layer, and the function of each layer differ from the network to network. The purpose of each layer is to offer certain services to the higher layer. Layer N on the machine, that is your source machine, will communicate with the layer N on the another machine, that is your destination machine. The rules and conversions used in the communication are collectively known as the layer N protocol. Basically, the protocol is the agreement between the two communication machines about how to communicate. Communication link should be established, maintained, and released. Violation of protocol will lead to the communication difficulties or failures. In that, small concept is peer. A three-layer network shown in the figure. The entitled the comprise the corresponding layers on different machines are called peers. The communication actually takes place between peer using the protocol. The light lines shown in the virtual communication and the physical communication is shown by the solid lines in the diagram. Why to have the layer protocol? The process of establishing a link between two devices to communicate and share information is complicated. There are many functions which are to be taken into consideration to allow the effective communication to take place. To organize all of these functions, in organized way, the designer failed to need to develop the network architecture. In the network architecture, various tasks and functions are grouped into the release manageable sets of layers. The network architecture can be defined as the set of protocol that tells how every layer is to function. What are the benefits of protocol layering or network hierarchy? It simplifies the design process as the function of each layer and their interactions as well as define. The layer architecture provides the flexibility to modify and develop the network services. The number of layers, name of layers, and the task assigned to them may change from network to network. But for all networks, always lower layer offers some services to its upper layer. The concept of layered architecture is new way of looking at the network. Addition of new services and management of network infrastructure become easy. Due to segmentation, that is your layer structure, it is possible to break difficult problems into the smaller and more manageable tasks. Logical segments allows the parallel working by different teams on different tasks simultaneously. Another benefits are interoperability, greater compatibility, better flexibility, increased expectancy, scalability, mobility, cost-effective quality, and portability. As there are some benefits, there are some disadvantages of protocol layering. The problem associated with the layered protocol is we lose the touch with the reality. Layering is the kind of hiding information, and layered architecture can sometimes result into the poor performance. Next point is OSI model. The of computer networks are located over the wide physical range, that is all over the world. Therefore, to ensure the nationwide and worldwide data communication system can be developed and compatible to each other, an international group of standards has been developed. The standard will fill into the framework which has been developed by the International Organization of Standardization, that is ISO. This framework is called as the model for open system interconnection, that is your OSI model, and it is normally referred as the OSI reference model. As shown in the figure, it has 7 layers of architecture of ISO OSI reference model. It defines 7 levels or the layers in the complete communication system. The lowest layer is the physical layer and the highest one is called as the application layer. The more So we'll go by layer. So first lowest layer is the physical layer. Function of the physical layers are as follows: to activate, maintain and deactivate the physical connection, to define the voltage and data rates needed for the transmission, to convert the digital data bits into the electrical signal, to decide whether the transmission is simplex, half duplex or full duplex. It does not detect or correct the error. A physical layer does not perform the following operations, that are: it does not correct the errors, it does not decide the medium or the modulation. The example of the physical layer protocol is RS-232 and RS-449 standards. Second layer is data link layer. The function of the data link layers are synchronization and error control for the information which is to be transmitted over the physical link. To enable the error correction, it adds error detection bits to the data which is to be transmitted. The encoded data is then passed to the physical layer. These error detection bits are used by the data link layer on the other side to detect and correct the errors. At this level, the outgoing message are assembled into the frames, and then the system waits for the acknowledgement to be received after every frame transmitted. Correct operation of the data link layer ensures the reliable transmission of the each message. Example of data link layer protocols are HDLC, SDLC, and X25 protocol. Next, layer 3 is the network layer. The functions of network layers are to route the signal through the various channels to the other end, to act the network controller by deciding which routes data should take, to divide the outgoing messages into the packet and to assemble incoming packets into the message for the higher level. In short, the network layer acts as the network controller for routing the data. Next layer is fourth layer, transport layer. As the name suggests, the layer provides the transport services. The function of transport layers are: it decided if the data transmission should take place on parallel path or a single path. It does the function such as multiplexing, splitting, or segmenting on the data. Transport layer guarantees transmission of data from one end to the other. It breaks the data group into the smaller units so that they are handled more efficiently by the network layer. Next layer is session layer. This layer manages and synchronizes conversation between two different applications. These are the level at which the user will establish the system to system connection. It controls logging on and logging off, user identification, billing, and session management. In the transmission of data, one system to the another system, at the session layer, stream of the data are marked and resynchronized properly so that the end of message are not prematurely and data loss is avoided. Next, level 6 is presentation layer. The presentation layer makes it sure that information is delivered in such a way form that our receiving system will understand and use it. The form and syntax of the two communication system can be different. For example, one system is using ASCII code for file transfer and another one is using IBM's EBCDIC. Under such conditions, the presentation layer provides the translation from ASCII to EBCIC vice versa. Next layer is last layer, your application layer. Application layer is the at the top of all layers. It provides the different services such as manipulation of information in various ways, retransferring the file of information, distributing the result to the user who is sitting above the layer. The functions such as login or password checking are also performed by the application layer. Next is your second model, TCP/IP protocol suite. This is the other reference model which was used earlier by the ARPANET, and then it is being used into the internet. TCP/IP is the short form of Transmission Control Protocol and Internet Protocol. ARPANET was research network sponsored by the US Department of Defense. It includes many universities and government installations using leased telephone line. Later on, the satellite and radio network were added to it. The inclusion could not be handled by the existing protocol at the time, so the new reference architecture were needed. This is new architecture is known as TCP/IP reference model. Due to the use of two protocols, TCP and IP, while the designing new model, certain goals were achieved. The first is design goal was to have an ability to connect the multiple network together in a seamless way. Another goal was the network should be able to survive loss of subnet hardwares with the existing conversation not being broken. Next goal is a flexible architecture were needed to deal successfully with the divergent requirement of various applications. So basic introduction of TCP/IP model is the internet protocol is like any other communication protocol is set the rule which will govern every possible communication over the internet. Since the development of ARPANET, TCP/IP together has emerged as the controlling body. It is using in the computer not only the US but all over the world for all the type and sizes of computer. It becomes a language of the internet. TCP/IP has two protocols. First is TCP, Transmission Control Protocol, and second is IP, that is Internet Protocol. These two protocols describe the movement of data between the host computer on the internet. The protocol, however, is a suite of many other protocols which provides for reliable communication across the internet and the web. In the TCP/IP protocol suite, there are various layers, which each layer being responsible for the different facets of communication. The Internet Protocol, IP, and Transmission Control Protocol, TCP, are together known as TCP/IP protocol. TCP/IP offers simple naming and address scheme whereby different resources on internet can be easily located. Information on the internet is carried in the packets. The IP protocol is used to put the message into the packet. Each packet has the address of sender and recipient. These addresses are known as the IP addresses. Using the TCP/IP protocol, a single large message is divided into the sequence of packet. Each is put into a IP packet. The packet are passed from one network to another until they reach their destination. At the destination, the TCP software reassembles the packet into the complete message. It is not necessary for all the packets in a single message to take same route each time it is sent. So basically there are four layers into TCP/IP model. So first we compare the TCP/IP model with the OSI layer. OSI has 7 layers. First layer of OSI and second layer of OSI, that is physical layer and data link layer, are combined to form a host to network layer, that is your layer 1 link layer. Second is network. Third of OSI model is network layer, that is your internet layer in the TCP/IP. Fourth layer of OSI model is the transport layer of the OSI model. As in the TCP/IP, transport is the third layer. And next are finally OSI has three layers: session layer, presentation layer, and application layer. In TCP/IP model, all these three layers are merged into the application layer. We will go by layer in detail. First is your data link or host to network layer. This is lowest layer in the TCP/IP reference model. The host has to connect the network using some protocol so that it can send the IP packets over it. This protocol varies from host to host and network to network. Second layer of TCP/IP model is internet layer. This layer is called as an internet layer and it holds the whole architecture together. The task of this layer is to allow the host to insert the packet into any network and then make them travel independently to the destination. The order in which the packets are received can be different from the sequence in which they were sent. Then the higher layer are supposed to arrange them in the proper order. The internet is being used as the generic term. The internet layer defines a packet format and the protocol called internet protocol, that is your IP. The internet layer is supposed to deliver the IP packet to their destination. So the routing of the packet and congestion control are important issues related to this. Hence the TCP/IP internet layer is very similar to the network layer in the OSI model. Next, layer 3 is transport layer. This is the layer above the internet layer. Its functions are same as the transport layer in the OSI layer. This layer allows the peer entities of source and destination machines to converse with each other. The end-to-end protocols used here are TCP and UDP. UDP is user datagram protocol. TCP is a reliable connection oriented protocol. It allows a byte stream transmitted from one machine to be delivered to the another machine without introduction of any error. TCP also handles the flow control. UDP, user datagram protocol, is the second protocol used in the transport layer. It is unreliable connectionless protocol and used for the application which do not want to the TCP sequence or the flow control. UDP is also preferred over the TCP in those applications in which prompt delivery is more important than the accurate delivery. It is used in the transmission speech or video. Next layer of TCP/IP protocol suite is application layer. This is last layer. TCP/IP model does not have the session or presentation layer because they are little important in the most application. The layer on the top of transport layer is called as a application layer. The protocol is related to these layers are high level protocols such as virtual termination, telnet, file transfer, FTP, and electronic mail, SMTP. Many other protocols have been added to this over the years, such as domain name services, that is DNS, NNTP, and HTTP. Thank you.